Good morning dear students. I am going to solve the problem of total internal reflection which relates the refractive index and the critical angle. In this while solving the problem, I am also going to use the absolute refractive index value. Okay. Well, when I start to solve, you just recall the concepts. Okay. Let's see the first problem. What's that? The velocity of the light in a liquid is 1.5 into 10 raised to 8 meter per second and in air is 3 into 10 raised to 8 meter per second. If the ray of light passes from liquid to air, what you have to find out? Calculate the critical angle. We know the relation, that is critical angle and the refractive index. What's that? N is equal to 1 by sin c. But n is not given. But one more again, what is the given thing? The velocity of light in a liquid is given and velocity of light with respect to air, that value is also given. We know that. Okay, let's see the solution of the first problem. We know the relation n is equal to c by b. That is the definition of the absolute refractive index. Or we can define the absolute refractive index. It is the ratio of the speed of light in air to that of the speed of light in the vacuum. Okay. And relation between the refractive index and the critical angle was that n is also equal to 1 by sin c. Since the LHS of both equations, then I will equate. What I get? N is equal to c by b will be equal to 1 by sin c. Okay. So the term c indicates the speed of light in air, b is the speed of light in liquid, and this is the critical angle. Okay. What you have to find out? You have to find out the critical angle. Okay. You have to find out the critical angle. Given thing is the velocity of liquid in velocity of light in a liquid is 1.5 into 10 raised to 8 meter per second. Next one. Speed of light, you know that the standard value 3 into 10 raised to 8 meter per second. Okay. I will use these two equations or these two relations. C by B equal to 1 by sin c, or I will write sin c equal to what? V by c. Okay. What's the value of V here? 1.5 into 10 raised to 8. Okay. What's the value of c here? 3 into 10 raised to 8. If you simplify, what you will get? 0.5. Okay. So c can be written as, that is critical angle, sin inverse of 0.5. For how much degree of sin function the value gets? 0.5. Okay. The value is how much? That is c is equal to 30 degree. If you forgot the value, just go through your log table book. In that natural sign, okay, the value 0.5 comes to 30 degree 0 minutes. The value 0.5 comes for 30 degree 0 minutes. Okay, it's the solution of the first problem. Clear? Okay. Let's go to the second problem. If the, similar to first one, if the speed of light in glass is 2 into 10 raised to 8 meter per second. The speed of light in glass is how much? 2 into 10 raised to 8 meter per second. Okay. What you have to find out? What is the critical angle of the incidence of light traveling from glass to air? In the first problem, it was light was traveling from liquid to air. In the second problem, the light is traveling from glass to air. What you have to find out? You have to find out the, once again, critical angle value. Okay. Same formula I am going to use here. refractive index and the critical angle. The velocity of light in glass is given how much? That 2 into 10 raised to 8 meter per second. 2 into 10 raised to 8 meter per second. That is, speed of light in air is constant. That you know that value is 3 into 10 raised to 8 meter per second. Okay. If I use the relation, that is n is equal to c by b. Okay. C value is 3 into 10 raised to 8 upon 2 into 10 raised to 8. After simplification, how much I will get? That is 1.5. Okay, n is equal to 1.5. Next, we also know that n is equal to 1 by sin c, or sin c is equal to 1 by n. Simply we can write 1 by n. The value of n is 1.5. If we take the ratio, how much I will get? Sin c, that is 0.666. Recurring term, I will shift it to 7. 6667. Okay. Next, c is equal to sin inverse of 0.667. Okay. For this, you know that you don't know the value of this, so use the log table. That is for the natural sine. In your log table, for how much degree and for how much minutes, see, you will get this. If you don't get exact value, just find out the nearer value. Okay. What's that value? 6667. Okay. So initially, how much I will get? Actually, for 41 degree, 48 minutes. Okay, 41 degree, 48 minutes. I will get the value 665. Okay, for 41 degree, 48 minutes, the value is 6665. And main difference in that, if I add plus 1 minute value, plus 1 minute value, that value is 2. How to write that value? Finally, the sine of 41 degree, 49 minutes, my value is 0.667. What's that? For 41 degree, okay, in the natural sine, for 41 degree, 48 minutes, how much I will get? 6665. Okay. Then to get the exact or nearer value, I will add the 1 minute value, that is 2. How much I will get? Finally 0.6667. The sine value of 41 degree, 49 minutes, this value is this much. So finally the critical angle value is how much? 41 degree, 49 minutes. Okay. The value is 41 degree, 49 minutes. Okay. So for this, use the log table in order to see the value. Okay. Let's see the next problem. What's that? A point source of light is situated at the bottom of the tank. Okay. A point source of the light is situated at the bottom of the tank, filled with the water up to the level of 80 centimeter. Okay. Next, find the area of the surface of water through which the light from the source emerges. Okay. For that problem, I am going to draw the schematic representation. Okay. What they are given? If we consider one tank, point source is situated at the 80 centimeter. Value is how much? 80 centimeter. What you have to find out? If there is a point source, okay, what happens? Light ray travels here in such a manner inside the water, and finally it emerges outside the upper layer, and it appears like a surface, like a circular area, okay. Next, just recall the concept of total internal reflection. What's the total internal reflection main condition? Light rays should travel from denser to rarer medium, okay. And what is the second condition? The angle of incidence should be greater than the critical angle, okay. What do you mean by critical angle here? The angle or the incident angle for which refracted ray is 90 degree, then such angle is called as what? Critical angle. The angle of incidence for which refracted ray is 90 degree, such angle is called as what? Critical angle, okay. It is the water. You can see the cone structure here. I will do this exact half or normal to this point, okay. See here, O, P. The ray OP get incident at the surface of water and the air, okay. What happens here? The ray grazes the media which separates, or the surface which separates two media. That is that line. Below that line, the surface is, the area is for water, and above that the area is for air, okay. Nothing but it grazes the surface. Our PR is our refracted ray, okay. When this ray grazes the surface, if I draw the normal at this point, I can consider this value. What's that? OP value as our critical angle C, okay. And the refracted angle is how much? 90 degree. Similarly in this side also, if I consider this side, if it is P, this point is P, S. OS is the incident ray. If it grazes the surface, SQ will be the refracted value, and this will be the critical angle, okay. And this value will be 90 degree. You can see one circular area here like this way. From here to here, since it's a circle, this to this portion, okay. It is, I have taken it as Z, or I will take it as A, okay. For the circle, the distance AP acts as the radius of the circular surface. I will take it as small r, okay. So let's find out the area, okay. One more thing is given. The refractive index of water with respect to air is 1.33. This value is given, okay. The refractive index of water with respect to air, the standard value, n is equal to 1.33. 42 minutes. In nearly I get how much? That is 7513. For 48 degree 42 minutes, how much that value? 7513. Next, I am going to add the mean difference of 2 minute value. How much is that? 2 minutes, that is 4, which will be nearly to that 0.7517. Okay, so the value is 48 degree 44 minutes. Okay, 48 degree 44 minutes. So C is how much? 48 degree 44 minutes. The value is 48 degree 44 minutes. Okay. Next, in this triangle OAP, from triangle OAP, if this angle is C, this angle is also opposite angle. This value is also C. If it is C, this angle is also C. For that, I am going to use the trigonometric function, that is tan C is equal to AP upon OA. Okay, AP is nothing but our radius, that notation is R, and OA, that is the depth of the water inside the tank. How much is that? 80. Okay, or R is equal to how much? 80 into tan C. Okay, what's the value of tan C here? Or sorry, what's the value of C? Tan of 48 degree 44 minutes. For that, once again I am going to use the log table, that's of natural tangent. Okay, natural tangent. I will see the what's the value of 48 degree 44 minutes. For 48 degree 42 minutes, initially I will get 1383. It starts from 1 point. Okay, 1.1383. Next, 4 minutes value, somewhat difference, 14. I get nearly R is equal to 80 into how much? 1.13 plus 2 minutes value 1396. Nearly value 48 44 minutes is how much? 1.1396. Okay, I will get, if I multiply, that value will be 91.168 centimeter. 91.168 centimeter. Okay. Last, finally, what you have to find out? You have to find out the area of this circular surface. Okay, area of circle is how much? What's the formula? Okay, what's the formula to find out the area of the circle? You know that A is equal to pi r square. Okay, 3.142. Value of r is 91.168. If we substitute and finally simplify, how much I will get? 26115.06 centimeter square. Or finally, if I convert in terms of SI unit, I will get 2.61 meter square. So this much is the area of the circular surface. A is equal to 2.61 meter square. Okay. Next, okay, I will solve the last problem, that is fourth one. That is also simple. Critical angle for total internal reflection from medium to vacuum is 40 degree. Critical angle value is given. What's that? 40 degree is given. What will be the velocity of light in a medium? We don't know the medium. Okay, we don't know the medium, whether it is liquid or air, anything else. We have to find out, but we know the relation between refractive index and the critical angle 0.6428, n is equal to 1 upon 0.6428. If I simplify, I will get this value 1.55. The refractive index value is 1.55. Next, the relation between, that is the according to the definition of absolute refractive index, n is equal to C by B. Since it is with respect